Hello again, I'm Nex and welcome to our mini-test solving of our 11th lesson, the inverse functions. So let's get right ahead and get started. This mini-test was a bit shorter, so hopefully it didn't cause you too many issues. For the first one, the simple one, we had to find an inverse of 5x minus 4. So we use our three-step rule. We swap the variables, isolate y, replace y with f to minus 1, but we don't have to do this for this sake. And then we had to test by using one of these rules. So I'll use the function of the inverse of the function of x equals x. So plug in the inverse function, so x plus 4 divided by 5. Then put this all as x in the 5x minus 4. So we will multiply this all with 5 and then subtract 4 at the end. We see that 5's cancel out. Then we see that the 4's cancel out. And we're left with x equals x, which means that y equals x plus 4 altogether divided by 5 is our inverse of our function. Huh. Okay, so it seems like I lost a 5 here. Oh yeah, I cut it here instead of copied. Never mind, happens. Anyway, let's get right ahead with our second task. We had to find an inverse of... Am I blind or can I not read? Oh yes, f of x where the function is x squared minus 3 with condition of x is greater than or equal to 0. So we write it out as a graph. We switch the variables, including the condition. We isolate the y, we take the root of it, again, plus the minus. Now we have to determine the domain and codomain of the inverse and the normal one. So let's start with the inverse. So our domain is, well, basically which numbers can we put in. So that is the x's for us to get a defined y. And since the lowest y that we can have here is 0, well, as the condition states, we have to see when this would all equal to 0. So we check the numbers. That is when x equals to minus 3, aka the root is equal to 0. So this is our solution for the inverse. Now for the function. We see that this is our condition, so obviously our domain is already defined as x is greater than or equal to 0. As for the codomain, let's insert 0 in as x. We have 0 squared is 0, minus 3 is minus 3. So with increasing x, that is already gonna increase, so our codomain is y is greater than or equal to minus 3. This is the simple solution to the second problem. Hopefully this didn't cause you too many problems, as we did solve this in the video. Next up, true or false. A student claims that the inverse of f of x, that is 3x plus 2, is equal to the inverse of f of x, that is equal to 3x minus 2. So essentially they're claiming that the inverse function is basically just switching the sign here. Well, we either do the math and find the real inverse of this function, or we can just do this proof. Since this one is faster and easier, I assume most of you went for this one. I will not judge you. I would probably do the same thing. If you did try to find the inverse, I am very proud of you, and we will see if you solved it correctly after. So, paste in the inverse function that we're testing, so 3x minus 2, and then put this as the x of the normal function, so multiply it all with 3, and then add 2 at the end, which gives us 9x minus 4, which equals x. We did not get 0 equals 0, so this is obviously incorrect. Well, incorrect. This means that the student's claim is incorrect, so false. Now, the real inverse is x minus 2 divided by 3, or 1/3 of x minus 2. So if you did try to find the inverse of this function, and you did this one correctly, I am super proud of you, good job. Applause, I would clap, but that would sound very suspicious and not safe for work on YouTube. And if everything went well, congrats, you are a master mathematician, mathemagician, because math is magic. And thank you all for tuning in to today's mini test solving and the lesson that we had a bit before. And I'll see you guys next time. Until then, see ya.